Analysis of function 1. In this video, we will learn about polynomial function which is cubic. Understanding its derivative is necessary to determine critical point, interval of increase and decrease, concavity, and point of inflation. This analysis helps the precise drawing of the graph showing the general behavior of the function.
Problem statement, we are given the function fx equal to negative x cubed plus 6x squared minus 9x. Our objective is to analyze this function by addressing the following points. First, we need to determine the y-intercept of f by identifying the point at which the function crosses the y-axis. Second, we need to find the critical points of f by calculate where the first derivative of the function equals 0 to identify potential maximum, minimum or saddle points. Third, we need to determine the intervals where f is increasing or decreasing using the first derivative test to find these intervals. Fourth, we need to analyze the concavity of f by determining the intervals where the function is concave up and concave down using the second derivative test, and identify any inflection points where the concavity changes. Lastly, we need to sketch the graph of f by using the information gathered from the previous step.
So how to solve the analysis of function? Let's say the given function is negative x power of 3 plus 6x power of 2 minus 9x. The first step is find the x-intercept and y-intercept. To find x-intercept, we need to assume y is equal to 0. And we need to substitute the 0 into a given function to get the value of x. Then, we need to find the y-intercept. To find y-intercept, we need to assume x is equal to 0. And we need to substitute 0 into the given function to get the y value. After we determine the value of x-intercept and y-intercept, we will get the coordinate. Step 2, we need to find the critical point. To find the critical point, we need to differentiate the given function. From the given function, we will differentiate it to get the value of f prime x. And the value of f prime x is equal to negative 3x power of 2 plus 12x minus 9. And now we need to solve this function to get the value of x. After that, we need to substitute x value into the given function to get the y value. After substitution, we will get the coordinate of critical point.
Now, for question C, in analyzing the function fx equal to negative x cubed plus 6x squared negative 9x, we perform a sign analysis of its first derivative f prime x to determine the intervals where f is increasing or decreasing. By solving f prime x equal to negative 3x squared plus 12x negative 9, we find the critical points and create a sign chart. This analysis reveals that f is increasing on the intervals 1, 3, and f is decreasing on the intervals negative infinity 1, also 3 infinity. From this, we identify the relative extremum point of the function, a maximum at 3, 0, and a minimum at 1, negative 4.
Next, for D, we need to find concavity, whether it is concave up or concave down. First, from first derivative equal to negative 3x squared plus 12x minus 9, we need to differentiate it, and we will get second derivative equal to negative 6x plus 12. So, 6x minus 12 equal to 0, 6x equal to 12, and the answer for x equal to 2 and x equal to 0. Find analysis of second derivative table. Second derivative is negative 6x plus 12. So, x smaller than 2, we put here is number 1. Put it in this equation. So, we will get positive. And the concave is concave up. Next, for the x bigger than 2, we put the 3 in this equation. So, we will get negative. So, the concave is concave down. So, the conclusion is f is concave up on negative infinity 2 and f is concave down on 2 infinity. For inflection point, y equal to negative 2 power of 3 plus 6 open bracket 2 close bracket square negative 9 open bracket 2 close bracket, we will get negative 2. So, the answer for inflection point is 2, negative.
Last step is we need to sketch the graph. After we determine the coordinate from the previous step, we need to plot the coordinate. After plot the coordinate, we need to connect to show up the curve. And we're done. In the conclusion, differentiation in the analysis of function is the key to identifying points such as minimum point, maximum point, and inflection point. Moreover, differentiation helps to determine interval, whether the function is increasing or decreasing, and to identify the concavity, whether it's concave up or concave down. This collective information enables us to sketch the accurate graph of function, and due to its versatile and applicable, differentiation stands as a fundamental tool to mathematical analysis and problem solving.